section 3.5, and we're going to talk about trigonometric derivatives today. Let's start out with some etiquette and notation. All trig functions need an argument. That means there's got to be an angle here. You can't write sine equals a half. Now, even in your head, if you're thinking sine theta equals a half, don't skip the theta on paper. So get into good habits, not bad habits. Powers of trig functions, by definition, if we put the exponent over the trig function like this, then that means we're taking, for example, sine of x and then raising to the nth power. And that's very different than putting the exponent just over the x. And this notation of powers of trig functions also works for logarithms. So for example, if you want to square ln x, you can write it as ln squared of x. Okay, the derivative chart. If x is in radians, these are the derivatives of the 6 trig functions. And you do need to memorize this. There's just no way around it. Now you can see that some of the derivatives are negative and some are positive. And a mnemonic device is, if the trig function starts with a c, its derivative is negative. And so think of c as standing for change the sign, and that will help you out. Now, geometrically, let's just look at the fact that the derivative of sine x is cosine x. The derivative is the slope of the tangent. So sine x has a horizontal tangent here and here. And sure enough, we can see that's exactly where cosine x crosses the x-axis. Furthermore, between those two horizontal tangents, all the slopes of sine are negative. And sure enough, the graph of cosine x is below the x-axis. All right, I've got a proof of the fact that the derivative of sine x is cosine x, and you can read that as at your leisure. And then we're going to jump into some examples. So find the derivative of 2x cos x. So for this, we've got a product of two functions of x. If that was just a 2 there, not a 2x, I wouldn't need the product rule. But I do, so let me just remind you, fg prime is f prime g plus fg prime. That's the product rule. So y prime is the derivative of 2x is 2. I multiply by cos x, and then I add on 2x, and the derivative of cosine x is negative sine x. And you need the parentheses there, otherwise it's going to look like subtraction. And then we'll do some cleanup. It's common to take the minus and pull it out. So this would be 2 cos x minus 2x sine x. There's our derivative. Okay, next one, find all values of x where the tangent to tangent x is parallel to y equals 2x. So our game plan here is set y prime of x equal to 2. And the reason is that y prime will give us the slope of the tangent, and the slope of this line is 2. And so we want the slopes to be equal for parallel lines. So first let's find y prime. Y prime of x is secant squared x. And I've got a proof of that on the last page, although it is in your chart of things to memorize. And we want to set that equal to 2. All right, well, secant squared is 1 over cosine squared. We're setting that equal to 2. Take the reciprocal of both sides of that equation. Think of 2 as 2 over 1, and literally just flip both sides. Cosine squared x is a half. Now, we want to solve for cosine, so we're going to have to take the square root of both sides, but when you do that, you have to take plus or minus. So cosine x is plus or minus the square root of a half. Now, the square root distributes over the top and the bottom, so that's plus or minus. The square root of 1 is 1, and then 1 over root 2. All right, let's move up here because I've run out of real estate. Cosine of x will be plus or minus 1 over root 2 at this angle, this angle, this angle, and this angle on a unit circle. And so that's x equal pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, why don't you pause the video and try this one yourself? All right, hopefully you did that. So we want equation of the tangent line at pi over 3. So the first thing is we need the slope. So first let's find y prime of x. Y prime of x is 3 secant x tangent x. 3 is a constant multiple, so I take 3 and I multiply by the derivative of secant. Now, we need the slope. M is y prime at pi over 3. So one is a function, one is a number. So this is going to be 3 secant of pi over 3, tangent of pi over 3. And I've got a little warning here on the right. Don't write y prime equals both of those. They can't both be y prime. One's a function, one's a number. Okay, so on a unit circle, pi over 3 is here. So secant of pi over 3 is 2, and tangent of pi over 3 is root 3. So our slope is 6 root 3. Now I need x naught, y naught in the point slope formula. X naught is given to me. That's pi over 3. Y naught is going to be y of pi over 3. So I want 3 times secant of pi over 3, which is 2. So my x naught, y naught is pi over 3, comma 6. Now I can do point slope. Y minus y naught, so that's y minus 6, is m, which is 6 root 3, times x minus x naught. X naught is pi over 3. And I want to leave it in point slope form, so I'm done. Here's another one. Find h prime of x and h prime of 5 pi over 6. So one's going to be a function, one's going to be a number. Now I could use the quotient rule right here, and I'll remind you of the quotient rule. F over g prime is f prime g minus f g prime over g squared. So I could do that, but I'm thinking, well, I can simplify this. So this isn't h prime, this is h still. H of x is 2x squared. Tangent is sine x over cosine x. And I'm dividing by secant, which is 1 over cosine. So that means I'm multiplying by the reciprocal, cosine x over 1. Those cosines cancel, and I get 2x squared sine x. Now that's a lot easier. I can just use the product rule on that to find the derivative. So now I'm writing h prime of x because I'm about to take the derivative, and I'm going to use the product rule. So the derivative of 2x squared is 4x. I multiply by sine x, and then I add on 2x squared times the derivative of sine x, which is cosine x. So that's the first part of my answer. That's my function. And now I want h prime of 5 pi over 6. Okay, so on a unit circle, 5 pi over 6 is over here. So we're going to get 4 times 5 pi over 6. Sine of 5 pi over 6 is a half. So this really tests your knowledge of the unit circle. Plus 2x squared. X squared is 25 pi squared over 36. And cosine of 5 pi over 6 is negative root 3 over 2. Again, you need parentheses there, otherwise it looks like subtraction. And now if we clean that up, this 2 goes into 4 twice. And so this first expression simplifies as 5 pi over 3. And the second expression will be negative. And the 2's cancel. And I get 25 pi squared root 3 all over 36. And I can leave it like that. Okay, last one. Find all the values of x in the interval 0 to pi over 2, where this function has a horizontal tangent. All right, our game plan. Horizontal tangent means m equals 0. M is the derivative. That's the slope of the tangent. So what I want to do is set y prime of x equal to 0 and solve for x. And I only want angles in this interval. All right, y prime is 2 cos x minus 2 sine x. And I want to set that equal to 0. Notice I'm indicating to the reader what I'm going to do at the top there. That's best practice. And so when I set that expression equal to 0, I get cos x equals sine x. There's a 2 on both sides, which I cancel. All right. Well, cosine is equal to sine in 2 places. Up here at pi over 4 and down here at 5 pi over 4. So there's 2 answers. Cosine is equal to negative sine over here at 3 pi over 4 and at 7 pi over 4, but I don't want those. All right, and finally, I'm just going to let you read through this proof that the derivative of tangent x is secant squared x on your own. Just a couple of comments here. I used the quotient rule here. I thought of tangent x as sine x over cosine x, and I used the quotient rule. And then I used the Pythagorean identity on the numerator. Cosine squared x plus sine squared x equals 1. Okay, and that is the end of this section.